In the last chapter, we learned about lists, and in this chapter, we're going to learn about something called a dictionary. Dictionary is actually a generalization of a list. In a list, they're always indexed by an integer. The integer starts at 0 and goes up to 1 minus the length of the list. Dictionaries can be ordered by, well, I don't want to say anything, but much more general kinds of indices. As long as that indice is what's called immutable, in other words, it can't change, you can index a dictionary with it. Okay, so I'm going to give you some examples of just creating some dictionaries and give you an idea of what they look like. In my first example, I'm actually creating a small dictionary for Python, meant kind of as a joke. So start off, and there's many ways to create a dictionary. So here's one method where you start off with an empty dictionary. The way you do that, there's a command dictionary, just open parentheses, and that makes an empty dictionary. And then you can start adding items to it. You use the indexed syntax, so brackets, and in this case, instead of using a 0, or 1 or 2 or an integer as my index, I'm going to use the word if. And so I want to define the word if. In this case, I'm calling it an operator meant to cause students problems. I'm also defining what else means and GitHub. So we've had some experiences with GitHub. Not all of them have been positive, let's say. And then I can print out that dictionary. And here's the cool thing. I don't have to remember where the definition for GitHub is. I don't have to remember that it's in position 2. It's the third thing in the dictionary. I can reference it as GitHub. Actually, I shouldn't reference it as being at position 2 because dictionaries are not necessarily ordered. So maybe the third thing that I've added to the dictionary, and I can't guarantee that that's where that's going to be if I try to print it out, for example. So I can print out Python dictionary. GitHub could be the first thing in the dictionary. Here is another way to build a dictionary. So I'm going to create a dictionary called Alphabet. And the syntax is you start with a left curly brace and then end it with a right curly brace. And inside, you have the key. In this case, the keys are going to be letters. So these things that we call, or I've been calling indices for dictionaries, we call them keys. And the key in this case are going to be letters, and then the values are going to be the position of that letter in the alphabet. So A will be 1, B will be 2, C will be 3, D 4, and so on. And again, I can print out that dictionary alphabet, and I can print out the alphabet value for key value B. Here is another method for creating a dictionary. So using the ICT command again, but this time I'm going to pass it parameters, and I'm going to build a dictionary that associates the word 1 with the numeral 1, 2 with the word numeral 2, and 3 with the numeral 3. Notice that I don't have these in parentheses. So these are not strings like I did up here. So in this notation, or this way for building dictionaries, you don't use strings. Although if I try to print it out, it will. There's one thing when you're doing this with keys, building a new dictionary down here, and it's related to alphabet, but I've defined the key A twice. And the effect is going to be that this initial representation for A is going to be overwritten, and this is going to be defined as 3. And I'm missing white space, so PyCharm's letting me know that. Okay, so let's run this and see what happens. Okay, so I'm printing off the Python dictionary, and what we find is this is actually in this what I call the set builder notation when you print it out. So here's a definition for GitHub. So remember, we put this in third, but came out first. And then here's the definition for what I've called GitHub, a definition for else, and then at the end, we'd have a definition for if. Now in this case, it turned out to be in reverse order, but it doesn't have to be that way either. And then I printed out the definition for GitHub. So we have associated with GitHub this definition in a dictionary, and so when I print Python dictionary GitHub, then you're going to get out the definition. And then alphabet, we print that out. Again, this is in a different order than I've defined it. So dictionaries, if you want something to be in a specific order, don't use a dictionary. Use a list. And if you need something with an index that's maybe not an integer, then you should use a dictionary and not a list. So those are some of the differences between dictionaries and lists and why you should use one versus the other. And with the letter B, which I printed out here, I've asked for alphabet B. B is the second letter in the alphabet. And then the last thing, again, we had A defined as a key value twice, and in this case, it took A to be associated with 3. I'm not even sure that's predictable. It's generally just a very bad idea to have a key associated with 2 different values, so don't do that. I actually have a little yellow warning down here that I'm ignoring that says, hey, don't do that. There are methods that you can use for dictionaries. So I've made another kind of dictionary where this is a list of different kinds of desserts, and then I've associated with the different types of desserts, different flavors for each type. So we have desserts and 3 different types of desserts: cookies, cake, and ice cream. And then for the key value cookies, you can associate any kind of value that you want. So this is the key cookies. I think I said key value, which is not what I meant to say. For the key cookies, you can have a value that's anything. In this case, the value is a list. So cookies is associated with a list of cookies: chocolate chip, peanut butter, and oatmeal. The key cake is associated with the value, which is a list of different types of cakes: chocolate, white, lemon. And again, with ice cream, different types of ice creams. So the value associated with a key can be any kind of data structure used in Python. You could have another dictionary in here if you wanted to. Again, we can print desserts. And so this is getting into some of the methods that are associated with dictionaries. You can ask for the length of desserts, and that's going to be 3. There are 3 different types of desserts: cookies, cake, and ice cream. We can print out desserts, so we can ask, with cookies. So what kind of cookies are there? And this should give us the list of cookies. There's another way to do this. So this is an indexing method. There's also associated with a dictionary a get method. So I can do desserts.get cookies, and initially those are going to look like they do the same thing. There actually is an advantage to using the get method. If I do desserts.get pie, we don't have any pies in this dictionary. And if I do this, this is going to return none, whereas down here, when I try to do desserts pie, this is going to give me an error. And you know what happens when you get an error in Python? Your program's going to have some funny output. It's going to do bad things. It just doesn't really work that well for the user. So you're better off actually using the get method. It just works nicer, and then you can just check to see if it returns a value of none or not instead of trapping an error. And the other advantage to using the get method is you can specify a default value. So we can go desserts.get pie. It won't get anything. We can say, well, if it turns out there is no such thing as a pie, then, I'm missing white space. Please use a default value of apple pie. Well, in this case, I probably should have just said apple, not apple pie. So we'll fix this as we're talking. You can remove elements from a dictionary. So I can remove the cakes, and then I can look at specific things in a dictionary. So for ice cream, the ice cream desserts is a list, and then I can look at list 0, and it's black raspberry, and I can take that out. There is an in method. I can check to see if there are cookies in my list of desserts. So cookies in desserts, this should return true. And then the last method we're going to look at is here is another dictionary called pies, and pie only has one entry, and it's a dictionary for pies, apple, cherry, triple berry. And I can merge the two dictionaries together. So suppose that I want to put the pie desserts inside of the desserts dictionary, then you do desserts update and this dictionary pies, and then we'll add this dictionary to the desserts dictionary and put the results in the desserts dictionary. And then we'll print out pies and we'll print out desserts. Okay, so let's run that. Let's see what kind of, well, we have an error here. Why do we have an error? Well, that comes back up to, where did it go? There are no pies and desserts. So we have cookies, we have cake, we have ice cream at this point. Down at the bottom, we add pies in, but at this point, there are no pies. So this is going to return an error. So if I comment this out and run it, I won't get an error. So this will be a little more pleasant to look at. Okay, so we print off the desserts list first, and we get cake, cookies, and ice cream. Again, it's in random order. The length is 3, so we have 3 different types of desserts. Print off desserts cookies, and that is a list, so you can do any kind of list operation on that list that you want. Desserts.get cookies returns the exact same thing. So as I was saying before, this is a different way to index into the dictionary, and perhaps in some ways it's a better way. Because if we do the get pie, there are no pie. I should have said pies, but same result. There is no pie, there's no pies. So this returns none. And then this says, go find a pie that's an apple, or go find a pie. There is no pie. The default's apple, so it's going to return apple. So you can specify, again, a default value when you do the get command, which could be useful. We're going to delete the desserts cake and print out, and we see that this list is shorter than the initial, or sorry, not list, dictionary. This dictionary is shorter than the original dictionary. The cakes have disappeared, so now we just have cookies and ice cream. We deleted the black raspberry ice cream, so now the ice cream list is a little bit shorter. Are cookies and desserts? Yes, they are. And now we created the pies dictionary. We printed that off, and then we added it to desserts, and now desserts has pies in it. Okay, so those are some of the different methods that you can use with dictionaries. You can test to see if something is in a dictionary. You can merge dictionaries together, and you can index into dictionaries using a get command, and you can look at the length of a dictionary. So one more example to just get a feel for ways to use these. We've done this before using lists with bands and various albums that they have created. So here's a list with Van Halen, and inside. So this is a double list. It's a list of lists, and inside each one of these lists, there's a band and different albums that band has written. So this is one way to create, I guess, a database of bands and their music, but I think a dictionary might be a better way to do this. So I'm going to create a dictionary, and each key value is going to be the band's name, so it's fine to use a string for that. And then for each band, I'm going to have a list that has the albums that they've written. So we have Van Halen, their album 1984, and they have another album called Van Halen. Motley Crue has a couple albums in here. Dr. Feelgood, Theater of Pain, and a Big Bopper back from the 50s has Hello Baby. The problem, the advantage to using a dictionary over a list is, okay, print the first element in the list, but you have to know where is Van Halen in the list. So I have to know that this index 0 corresponds with Van Halen, and lists are ordered, so it's always going to be Van Halen. And I can ask for their second album, release the second album on our list. So this is going to reference Van Halen, the first band in the list, and then this is the list of songs, and that's the second element of that list. Or in the dictionary, instead of having to know that Van Halen corresponds with index 0, I can just say, what are the albums corresponding to Van Halen? You can loop through a dictionary just like you can loop through a list. So I can say for band in the dictionary Van Halen, and that's going to go through Van Halen, Motley Crue, and Big Bopper. Can't guarantee the order that's going to loop through, but it will loop through all of the different keys in the dictionary. So I'm just going to print out the keys. Apparently my indexing is bad here. I'm not sure which way I need to go. And you can also then remember that because this is a slightly more complicated structure than just a simple dictionary, for each key, the value is a list. So I can say for band in D, this is going through the keys for the dictionary, so the bands. And then for each band in that each band in the dictionary, there's a list of albums. So I can loop through each one of those lists. So D sub band is going to be these different lists here, and I can print out the band and the song. Let's see, I'm doing a music example. And this is just printing off the information for Van Halen in a couple of different ways. This is just comparing using the dictionary versus using a list, as I said before. And this is the for loop executing. So this is just going to go through the different keys, and the keys are the band names. And then this, for each band, goes through the list of albums in this second for loop and prints off the band and, well, I said song, but these are actually albums. So I should have said album. Oops. So Van Halen has 1984. Van Halen has Van Halen. Big Bopper has Hello Baby, and so on. Okay? So these are some examples of using dictionaries. Hopefully you get a feel for how useful these can be. And in the next installment in Chapter 11, we're going to go through a more complicated example using this idea of building up a dictionary to create a music database.